Next speakers are going to talk about phased service provisioning. So Martin Åkerström and Ravi Shankar, welcome up on stage.
No, I'll do it later. Is it audible? Yeah. Hey everyone. Thanks for joining the session. For the next 30-40 minutes, me and Martin are going to talk about phase progeny. So before we start, a quick introduction about ourselves. I'm Ravi Shankar, Senior Tech Lead, working for NSO Core Function Pack team, based out San Jose, California. I have been with NSO right from the time Taylor got acquired by Cisco. It's been 8+ years.
Yeah, I'm Martin Åkerström. I'm currently one of 2 product owners for NSO. And one thing that I do as a product owner is go on stage and take credit for other people's work. Which is nice. But today I will also give some credit to Ravi, of course.
So let's see what we have in the agenda for today. So first, Martin will talk about why we needed this phase progeny. Then I will get into brief details and discuss more about the design and features. In design and features, I will talk about the main design elements and the execution flow and a few additional features. Then we'll see in live action demo. After that, we will wrap up this session with a quick Q&A discussion. Yep.
Okay. Yeah, so I will just try to sort of articulate the problem statement and why we developed this package. So I'll try to illustrate that in a way that everyone understands, and that's with rabbits. So imagine you have a product. Obviously, the plastic cups on the picture are NSO, and the rabbit is the, I don't know, service developer. So you have a tool which is very flexible. You can do multiple things. I mean, you can have them stacked like this, or you can stack them like this. So obviously, 2 different ways of using the same product. Although not always is it a good idea to do this at the same time, because these are sort of conflicting, so you get some resource allocation errors because you don't have enough resources to do it all at the same time. So if you do this task over and over, it will take a longer time if you try to do them at the same time. And that will kind of end up in a sort of more of a chaotic way of doing things, and it takes longer time. So we need a way to control that, is the general idea. And yeah, obviously these are not a perfect illustration of the problem, but you have to understand it's really hard to get rabbits to do what you intend them to do. So eventually I gave up. I think I'll move on. So one use case described to us where like a customer use case that was described to me at least for this problem is that sometimes you have different teams doing different things, of course. You have one team that provisions stuff, and you have another team that may be onboard devices and all those things. So in this particular case, they had like team A who usually started to work in the morning. And since they started to work at around 8 a.m., that's also when they started to push things to NSO and do a lot of things because they had the backlog from last day that they were just trying to push through. Obviously, they worked the whole day, of course, but most of the work they are doing with NSO gets concentrated in the morning, since that's how they start. And yeah, and maybe they do some things in the end as well to finish off the day when they have collected all things that they need during the day and such things. And then you have team B, who starts to work like the same time, and they are also doing all the backlog items they have from previous day and things that happened during the night. So they also start pushing things to NSO at the same time. And I mean, that's entirely possible, of course, depending on what type of services or what things you are doing. But sometimes, if there is a lot of things happening, you get some resource issues, of course, because there might be a lot of things. Maybe they are calling a lot of API calls, or it's something happening in the service that consumes a lot of memory or CPU resources. So you get timeouts and things if they run actions. So they very much like to try to, they don't want to wait with starting to work until 11 a.m. or so, because at 11 a.m. you eat lunch. I hope everyone understands that. But anyway, yeah. So they need a way to work together. And in this case, they were completely different teams, so it's hard for them to correlate what they were doing. And some of the things they were doing are of course, perfectly okay because it were in separate times, but some things overlapped and you had a lot of issues with that. So the idea with phase provisioning is that you can still do whatever you do at the same time that you do it, but you queue it up in NSO so that the actual work in NSO happens at a later defined time window. So in this case, I mean, whatever they did in the afternoon, they can still keep doing, but the things didn't really start to happen until at night, because they know that during nighttime no one was using the system and they had a lot of resources available, so they can let everything happen during the night. And same as for the team working in the morning, with this setup, they can still start their day, do all the work, but in the case spread the load across the whole day in shorter chunks of time windows where it's less load on the system or yeah, like that. So they can still use the same work schedule, but they can spread the load across the day and during the night. So that's one problem that we try to solve with this. I mean, it doesn't have to be competing teams that works. It might be that you are pushing really heavy stuff towards NSO, which NSO can't handle in that amount of time. So you also want to phase it a bit. So you only do, like, if you're pushing to a couple of thousand devices, maybe you want to do 50 devices at a time at certain time windows, just to spread load across the system so you don't block the system for everyone else. So that's, I think, yes, that's my setup to Ravi. So now he can show you how it actually works.
Thanks, Martin, for setting the context. So,
and I'll stand here and look really awkward and misplaced.
So with that said, let's see brief details about this. So phase provisioning is a Cisco NSO add-on package. When I say add-on package, it's like what you have already: resource manager, observability exporter. It's same. In the same way, it is also an add-on package, and just load it as a normal package and start using it. What it does, it helps in provisioning your tasks in a scheduled way with customer provided policies. And it allows to execute this task in a scheduled windows and or a period of time period. And it can be recurring also. So it can be either run immediately or scheduled way. And also it allows to test the instances you run as part of this task. And you test it and declare whether it's success or failure. And based on that, you can insert the framework to stop execution and or suspend execution and fix your issues, triage and fix the issue, and resume the provisioning again. So it's just a Python package implemented using Python and uses underlying NSO action scheduler and other export evaluation, those kind of things that will come with NSO. And it's available from NSO 6.1. So if you go to cisco.com and go to the location where 6.1 is loaded, there you should see this package also along with the other add-on packages. Let's get into the design and features. Mainly, as part of the design, I want to cover the main design elements we have in the Yang model. The first one is the task. A task is the one how you instruct the framework to where and what aborts, like where should you find and what to do, right? So the where is what the target node is about. A target node is like a root node in the root node of a list. So for example, if device is one of the target node. Similarly, service, or if you have L3 VPN container, L3 VPN's container and L3 VPN service, the L3 VPN will be like the root node. So when you provide that, we fetch all those instances under this, for example, device instances, and or you can provide an optional filter, which is an export expression, which says, okay, I want only the devices starting with this name or some field with the device net ID equal to this version. Then we filter based on it. Then the what is what you want to do. So the action you want to execute, right? The action can be as simple as if you are doing on a device, it can be a sync to or migrate. It need not be a provision thing itself. It can be a sync from also. Similarly, if it's a service node, it can be a redeploy or reactive redeploy or whatever other actions. If you have your own custom actions also, you can invoke it. And we have something called a policy that we associate with this task. I'll share more data about the policy in the later slide, in the next slide actually. But to give a brief introduction, it's like when and how is what policy is telling about. So task is like where and what, and policy is like when and how to execute it. And there's an optional self-test. So after executing that action, you want to do more checks, and based on that only determine whether the instance of that run is successful or false. That's what you provide self-test for. So the next design element, as I mentioned, is policy. So policy specifies like when and how to run the task. When is nothing but the schedule. If it is, it can be an immediate or it can be a scheduled one, which can be a recurring. So for the schedule policies, what we do is we create the underlying scheduler task the NSO has. We don't do any scheduling stuff. We just bank on the NSO scheduler task. And if it's a scheduled one, we can provide a time window also. Like Martin was saying, you want to run only for the maintenance time window and stop executing. And the next day maintenance window, again, you want to execute, right? So that's what the time window says about. Once we hit the time window, then we'll again stop and we'll wait for the next time window. And the other part is the batch size. It's like number of tasks you want to run in parallel. For example, if you are provide a device migrate action or like a service redeploy, and if you have 20 services to do, then if batch size is 2, then we do redeploy of 2 services parallelly. That's what the batch size is. In that way, we make use of the NSO 6.x concurrent enhancements. And the last one is error budget. So when you're scheduled, you may be hitting some errors when we are running the actions, and you may not want to execute continuously if you are hitting the errors on like more number of instances. In that way, you want to suspend the execution and triage the issue, and once you fix the issue in the network or the config, you may want to resume the execution, right? So that's what the error budget is. Like once the error budget is depleted, we'll suspend the execution, and that's when the user can triage the issue and resume it. So these are the main 2 design elements we have. Let's see what is the execution flow. If you want to use the package, first thing you'll do is create the policy. Then you create a task. Then you run this action. That's where things will, the framework will take those things and start doing whatever it's supposed to do, which I'll cover. And then you want to monitor the status. There's a show command you can run to monitor the task status, right? So with this execution, let's take a scenario and see how we do this, right? So case 1, the user really wants to migrate several devices in his device tree. Like in this case, he wants to migrate the device starting with the region B from net version 1.0 to 1.1. as highlighted in there. So he has other routers also. Maybe there's a mistake there. The other region B router also should be. So, okay. So now let's see how to use the framework to achieve this. So first thing he will do is to create the policy. And as you can see, the policy is a future policy. And it's typically the cron job syntax. That's what the scheduler expects, NSO scheduler. So it's here we are saying for every 10 minutes run the invoke the action that we provide, right? So, and we are given the time window as 300 seconds, which is like 5 minutes, just for the thing. It will run for 5 minutes, and then it will stop, and it will wait for the next scheduler to kick off. And here the batch size is 2, so we run 2 instances of parallelly, and the error budget is 1. So like, once you hit the first error, you're okay, but the second error is suspend the execution. The task you create is like this. So like the target is the device's device, and you want to only select the devices that are starting with the region B. And the action you want to run is the migrate action, and the action takes some variables, which is like new net AD and new net version. And the policy is referring to the above policy. And there is a self-test which checks whether the net version has been really migrated to 1.1 or not. That's the self-test. After that, we run the action and just monitor. Once the task has successfully run, you should see the status completed, and you can see the nodes that are picked up at region B. So more details in the demo I do later. So we'll see more about this in the demo. Similarly, the second case is now we are trying to do the service. Like Martin mentioned, you want to push the config changes during the maintenance window and not during the active business hours, right? Because during that, if NSO is being used as part of a solution in your organization, it has to handle the northbound requests and fulfill the customer requests more. And these kind of tasks, like, for example, if you have an audit and you have to update your NTP server or something, and you are given a time of 1 or 2 weeks, then you may want to do it every night during the maintenance window, and that should be fine, right? So for such kind of things, what you would do is like, you load the config, whatever you want, use commit no deploy, so that commit no deploy just commits the CDB, but it doesn't push to the network, right? As you all may be aware of it. So once we have that, then we come to the phase. We can use the same policy, but here we have some new policy. And we create the task. Here we are saying the target node as the custom service, which is the root node of the service you have. And like I'm picking up only then starting with demo and run the action and monitor the status. So I will show all this in a demo. So for now, let's go to the next slide. So here, what happens internally, the flow, I want to just quickly skim through it. So the user will commit the task and run the phase provisioning action. At that instance, the framework will, if filter is provided option filter, then it will filter the nodes, and we add it to a pending queue. Then, based on the policy, if it is an immediate, we'll start executing what we call as a batch processor. Or if the policy is a feature, we create the NSO scheduler task, which invokes an internal action that actually does this same batch processor thing. What the batch processor does is it will fetch the items from the pending queue and execute in batches. So for every item, it will make sure it will run the action, it will test it for every batch. Once the items are done, if there are more items left in the queue and the error budget is not depleted, it will just go with the next batch. And it should be within the time window. Once the time window is done and there are still items left in the queue, it will just wait for the next scheduler run to kick off. At any time, if the error budget has depleted, then it will suspend the execution. Or if all items are done, then it will come to a stop, right? So that's the internal flow. There are a few additional features, mainly like, as I was mentioning, once the error budget is depleted, the task execution is suspended. So now you go and fix your changes, and you know now things are good. Now you come and resume the task execution again, and we'll resume from the whatever items are in the pending, we start executing them again. And there is one more thing, which is like a brief action. So the show command, it may become cluttered when you have many number of instances that you're running. So this brief is like, it provides a matrix or statistics. So as you can see, this is the easy way to check the status of your run. So that's all I have for the slides. Enough in slides. Let's go to the demo. So before I get into the demo, let me connect my laptop and execute my. Oh, can't properly. So before we get into the demo, let me explain about the environment. So this is a local NetSim environment, and I am on NCS version 6.1. So all have the following packages. So the phase provisioning package is the main one that is loaded, and have two nets, XR nets, one which is 4.2 version, the other one is 4.6, and I have another sample router NC10 version that comes with our example NCS one. And there is one sample service, which is a static DNS service, just updates the DNS server IP in the device. That's I'll use for my demo. So as part of this demo, I'm going to cover 3 scenarios. First one is the success, where I will try to migrate the nets, migrate the device net version from one version to another. And the second one is similar case, but I will depict the failure scenario and where the error budget gets depleted, and I will use the resume action. And the third one is with the service node. Yeah. So before I do that, let me show you the device list. So I have some devices, region A and region B. They're running the 742 XRNet version. And have a few other devices which are using the sample net. Now let's try to run the scenario 1. So as I mentioned, in the scenario 1, I want to move the devices that are starting with the name region B from 742 to 746 version. I want to migrate the devices from XRCLI 742 to 746. So for that, let's see what we can do using. So I have already some payloads that I have stored in my laptop, so let me use those payloads. So as you can see, the task I have created is to devise it like as shown in my slide. Is the device's device, is the root node, and I want to select the devices that are starting with the name region B, the device name starting with region B, and I want to run the migrate action, and it takes some parameters, which are the new net agency version. And the policy, keeping in mind the demo time, I'm just saying to run for every 1 minute and run for only 15 seconds window. The batch size is 2 and error budget 1. And yeah, the testing is like to check whether this really moved to 4.6 or not, and I'm referring to this policy. So let's commit this, and I hope things are good. Yep. Now run the action that we have. Once you run the action, like I showed in the flow, things will get picked up and a scheduler will be created. So if you see the scheduler currently, nothing will be there, but let me run it for every 2 seconds so that here I'll run this. And you can see the scheduler has been created already. Now let me run the task status command for this net migration and keep it to. So what you should see is like you see the nodes we already filtered, region V routes. And once the scheduler is picked up, scheduler kicks off, you should see the nodes moving from pending to progress, and whenever they're completed, they move to the completed. So here we have more few nodes already completed, and these two are also getting executed and they're completed. And once we hit the 15-second time window, you will see there is a pause in the execution, and we'll wait for the next scheduler to kick off, which is again in a minute. Then we'll see the next set of devices being moved, again in the same way. And we can see the current error budget and the allocated error budget we are getting from the policy, and the current error budget we track of. If any errors hit, we'll keep track of that in the current error budget value. So here we should see the next scheduler kick off, and then the other nodes should move immediately. Yeah, the scheduler got kicked off, and we are migrating the other devices. And the last set are also getting migrated. Yeah, if you see here, things are completed. State is all nodes that are applicable for the given filter have been migrated. Let's see quickly in the devices list. As you can see, the required devices that are falling in that filter pattern, they got moved. So now let's go with the next scenario, which is a failed scenario. Before I do that, let me explain how I am trying to mimic. So this time I'm trying to move the region A routers from 4.2 to 4.6. Generally, that's what you do, right? If you're trying to migrate, you'll try to do the first one region, and then you go with the next region. That's what I'm trying to mimic. But here, deliberately, I have not done sync from or anything for these two devices so that the action fails and we exceed the error budget, right? So let's see. As you can see, I'm trying to use the same policy, and I'm trying to pick up the device starting with name region A. And we're expecting a failure here in this case, so let me commit it. And run the execute. Yep. And so yeah, things are moving already, and it failed. As you can see, there are two nodes that got completed, and there are two nodes which failed, which is as expected. And now the task status is suspended because we have depleted the error budget. It's -1 because we gave 1. Allocated 1 is 1, but we already hit second error. So now we know this task is suspended. So now let's resume the task. In the real world scenario, the customer may fix the issues in the network or whatever it is, and then he will come and try to resume the suspended task. And we are trying to reset the error budget so that things progress again. Let's see that. task status. Yeah, so it's in progress again, and whenever the scheduler kicks off, we should see the pending nodes move into in progress and then completed. At least the remaining pending nodes will go. So the other 2 failed nodes got added to the failed group. So, yep. And one more thing I want you to observe, the current error budget is reset to 1 because we gave the reset error budget to. As you can see now, the remaining nodes are in progress and they should get migrated successfully. Yeah, so they got migrated and state is marked complete. So let's check the devices list now. As you can see, except these 2 devices, the other devices which are starting with region A, they too got moved to migrate to net version 746. Cool. Yeah. So as the last scenario I want to demo is with the service node. Like we said, the target node can be any list root node. So it can be devices, or it can be services you have, or it can be any list root node in your config. So now the scenario I want to show is like the one that I said, the services one. So have let me stop this. So I have these services that are DNS that will set a DNS IP in the given device. I mean, this is the service name, and the device name also is the same. And I'm just trying to do commit no deploy so that it won't get pushed to the network. So if you see a show static DNS, you will not see any entries. Now I'll do commit no deploy. And here, if I do the same command, you can see there are a few services, but the device is not set because we didn't push anything to the network, right? So now let's use phase provisioning to do that. And in this case, what I would do is I am doing it immediately. I'm not doing it as a future one. And I'm just doing it only for the services that are starting with the name demo -. Let's see what happens. And here, if you see the policy, it's batch 1, so which means it will be like a sequential execution, right? So let's commit it. And now run the task, run action, which is the deploy DNS. Since it's immediate and the service is very simple service, I'll not be able to show you the progress. But here we can see, as the service executive, you should see the device getting populated. Yeah, that's done. As you can see now, since our filter is only for demo services, which only for these services, the device is populated. The other one still remains empty. And if you see the task status, right, it's completed, and the completed nodes are these things. Okay, so that's what I have for the demo. Hope that gives enough details on the package and how you can use it. What is this? These are the 3 scenarios I talked about. Yeah, so as next steps, you can go and download the package as mentioned. It's available already in cisco.com. And any feedback you have got, you can submit over the developer hub. With that, now the stage is open for a quick Q&A discussion. Thank you.
Thank you very much, Ravi. Martin, we do have some questions on Slido.
Sure, Martin is anyhow standing. He can take all the questions. Just
yeah, he seems to be great at pulling rabbits out of the hat, or whatever you're doing with them. Let's see here. Maybe Niels Petter is going to take this one. So grab the mic over there.
Okay.
All right.
Which one?
So one question is, does it cost extra?
So Ravi already showed you where you download it. So it's included in an NSO 6.1. So off you go. Don't wait.
It's already available for the.
Very good. So free is good, right? The other question for you, Niels Petter, is will this add-on package have better and proper long-term support compared to mentioned resource manager? So
that was kind of an interesting question. So of course it will be supported. And I will be available here for Meet the Engineer to discuss the experience of the support of a resource manager. I'm very interested in that kind of statement. But definitely it's part of the product, will be supported forever as the rest of the product.
Okay, let's switch to technical questions. Can this package be recompiled for earlier NSO versions?
I guess it's possible, but I don't think it's not intended for that. So
it's going to come out with 6.1 and be officially supported.
We have no intention of testing it with all versions.
Okay. Can we see this on OS cron tab?
No.
No? Okay. One more question here.
Well, let me elaborate. No. So.
All right, very good. Can you filter on regex?
So the regex I gave is on, the filter I gave is on regex only actually. Name starts with is a regex only. Right. Oh, you mean regex? Sorry, it's XPath only. Sorry, that's because we are dependent on the NSO evaluation, and right now we are supporting XPath expression only. Yeah, as of now there is no support for regex.
All right.
But yeah, maybe in future.
Okay, maybe final question then. What is the main advantage of this package versus existing scheduler and cron tab? That's for you, Martin.
Yes, I mean the advantage is obviously that we have more control of the queue that we want to execute on. And, I mean, of course, you can write your own stuff and put it in the scheduler and use cron tab, but here we give ways of have better control of it, and have the error budget. I think is an important part of it, and keeping really good track on how many instances we have done so far in each window and so on, I would say.
All right. Any other questions from the audience? There's one.
The test condition, can that be delayed? You want to wait for things to come online? The question was, could the test condition be delayed?
So we did think about it when we were developing this, but since this is the first version, we have pushed it out. But as part of the testing, you have an action also. You can provide your own action, and there you can have the delay and do the testing if you want to. So it's just an XPath expression and action also we have. It's a choice.
What about support for retries of failures? I assume, you could address them and then go do something to move them over to queue them again?
So as part of the resume, you are asking in the context of resume, right? So in the resume, we can do that, but maybe in the node, you know that the nodes or the devices, they're down and you don't want to execute on them again. So we may want to provide a different action to just pick up the failure nodes and execute them.
Indeed. You need some way of getting that data out if you want to eventually retry them after you've...
Yeah, so we have that already in pipeline, the retrying fail nodes. As you've seen, the fail nodes are already captured. We just need to have an action that just does the retry.
All right.
Yeah.
Thank you very much for this session.
Sure.